everybody. It is still April 12th, 2018. And what I am going to do here is this video is going to be part one of two. This is going to be a graphical representation of that video I made yesterday in my kitchen with my inflatable moon, or my inflatable Earth globe, and then my moon globe. But in this part, I'm just going to explain to you the vantage point you would be seeing at a certain latitude when you look up at the moon, say at moonrise. The second part is going to be, I'm going to actually take you through the night and show you that sway. I'm not going to do this here because I don't want the video to be ridiculously long. So we're going to pick a latitude. We're just going to start with that. But so this guy is standing at 60 degrees north. I want to say this is not to scale. Let me say that again. This is not to scale. All right. So this would be, just say you're looking at Earth and the moon from space. This would be a close approximation of what you might see if some guy was standing at 60 degrees north. Obviously, he's not going to be this big. It's to illustrate a point. So he's at 60 degrees north latitude. So now when you're standing on the Earth, when you look up at the sky, the best reference points you can have that are not in the sky is the horizon, your ground. And you're so small compared to the size of the Earth, that can be modeled as a straight line. All right. So I've added the horizon line here, which would be at the guy's 60 degrees north latitude, which would be a tangent line with the circle of the Earth that you see there. Okay. So now what we are going to do is we are going to mark Tycho crater, because that's going to be our mark throughout this, and the words are going to disappear, but you'll still see the red and yellow dot. Now, let's orient the horizon so that it's level to us, or level to the screen in this case. Okay, so how do we do that? Well, if we're at 60 degrees north, we need to rotate the image counterclockwise, in this case 30 degrees, because that's our complementary angle. 90 minus 60 is 30. So if we're at 60 degrees north latitude, we subtract that from 90, we get 30. And if we manually rotate this image, which I did here, you will find that it's rotated counterclockwise 30 degrees. All right? So in a right triangle, all the angles equal 180. All right? So one angle is always going to be 90, or it's not a right triangle. 180 minus 90 gives you 90. And in this case, we're at 60 degrees north latitude, so our complementary angle is going to be 90 minus 60, or 30 degrees. That's all you have to do. You don't even need to worry about the 180 minus 90. That was just to show you the right triangle, okay? Now that we have our orientations, let's work out the angles at Tycho crater. All right, so I'm going to show you two images, just like in this one. You're going to have the ecliptical view, if you will, on the right, and the horizon leveled view on the left. So here's what we have. So we've gotten rid of the guy and the Earth and the horizon. The moons are still oriented as they were in the previous slide. Left is left there as it is here, and right is right here as it was there. So, and Tycho crater is marked, as you can see. Now we're going to put a circle with crosshairs running through the diameter in an up, down, and left, right direction. And we are going to make some angles using Tycho crater. Okay, so viewed from the ecliptic, what you would see is you would see Tycho crater rotated 16.5 degrees to the left. And from your actual vantage point on the ground, you would see 13.5 degrees to the right, say at moonrise. Now this moon picture is just from online. This isn't actually representative of any orientation of the moon during any particular date or time. It does change throughout the year through libration, which I've talked about before. So we can use these to check ourselves here. 16.5 plus 13.5 is 30 degrees. 30 is our complementary angle to 60, our latitude. So when we add those two, we know that this is kind of like a secondary check, if you will. Instead of just rotating an image to the left, you can actually look at this and measure the angles of your disk to see what you would get. So you can kind of double check yourself doing this. But anyway, that's it for this part. Now, part two, I'm going to actually show you the sway during a hypothetical situation throughout the night and how you can use that sway, and where you can look at Tycho and make predictions, which I've done before. I've just never actually shown you how I do it, but I'm going to show you that in the second part of the video. But anyway, if you have any questions or comments, please feel free to leave them below, and I hope you all learned something.